Welcome back students. Today we are going to learn about a new chapter, changes around us. Okay. So, it is there in your textbook at page number 86, chapter number 6, changes around us. Okay, okay students? Okay. Shall we start the topic? Yes. So, children, in our day-to-day life, so many changes we are noticing, isn't it? Day and night, raw mangoes will ripen to form sweetened mangoes, isn't it? Yes, there are so many changes taking place. So, now in this chapter, we are going to learn about what are the different changes, and we are going to learn about the changes in detail. Clear? Yes. Yes children. Now, let us look about the mind map of the chapter. Okay. So, first, change. What do you mean by change? A noticeable difference in shape, size, color, state, internal structure or any other properties of a substance or an object is said to be as change. Clear? Now, this change is classified into two types. It is physical change or chemical change. So, physical change, physical property of a substance changes, but no change in chemical composition. Okay, only the physical property is changed here. The internal or the chemical composition does not change here. Okay, then again, this physical change is further classified into two types, that is reversible or temporary change, or else number 1 that is reversible temporary change, and number 2 that is irreversible change. Okay. So, here about the reversible change, what do you mean by reversible change? The original substance can be obtained as such. Okay, we can get the original substance. So, here melting of ice and then evaporation of water is termed as example here. Okay, is mentioned as example here, and then reversible change, example tearing of paper, bursting of balloon and all. Clear? Then about the chemical change. Chemical change, it is also termed as irreversible or permanent change. Okay. So, here the original substance cannot be obtained. After this chemical change, the original substance it cannot be obtained. Mean to say, the molecule of the original substances undergo changes to form the molecule of new substances. Original substances will get changed to new substances. For example, a piece of paper, when it is burned, it is turned to ash. This ash is termed as a new substance here, and we cannot get again the paper from this ash. So, this type of change is mentioned to be as chemical change. So, we are going to learn about all the different types of changes in this chapter. Yes children. Now, the proper definition for change. A change refers to a noticeable difference in shape, size, color, state, internal structure or any other property of a substance or an object. Okay. So, a change is nothing but a difference in shape, size, color or any other property. Clear? Now, this change is further divided into different types of changes. First, about natural changes. So, what do you mean by natural changes? Nothing which is changing naturally. For example, growing up of living things, shedding of leaves by plants, all these things are taking place naturally. So, that sort of changes is said to be as natural changes. Clear? Yes. Next thing about man-made changes. So, what do you mean by man-made changes? The changes are brought by the humans. For example, making a dress by cutting and stitching a fabric. We are changing the original form into different types of material, right? Like frock or churidas or anything. So, here since we are making a change, that is mentioned to be as man-made change. Clear? Yes. Now, based on some more properties, changes can be grouped as reversible, irreversible, physical and chemical. All are different types of changes. So, we are going to learn one by one in detail. Okay. So, first about reversible changes. Reversible changes. What do you mean by reversible changes? Changes that can be reversed to get the original substance. Changes that can be reversed to get the original substance are called as reversible changes. Yes children, now you can see the carrot model made by clay, isn't it? Yes. So, now we can change the shape of clay as like this carrot or any other fruit or vegetable or anything. Then we can change the model back to its original shape as like clay, the normal clay, isn't it? Yes. Now, this is one example of reversible change. That is, we can change to any other form and we can make it revert it back to its original form. Clear? So, this is what reversible change. Now, children, let us learn further. So, first about vaporization. What is this? When we heat water, it changes into steam, and this process is called vaporization. It is a simple process, isn't it? Yes. And then condensation. What do you mean by condensation? If the steam is cooled down, it changes back into water, and this process is called condensation. Steam is cooled down back into water, and that process is said to be as condensation. So, these two, that is vaporization and condensation, are examples of reversible changes. So, now children, let us explore further. You can have a look on this fallen leaf, isn't it? Yes. So, I am making this leaf into smaller pieces. Clear? Yes. Now, is it possible to make this small piece of leaf into its original shape like this? No, isn't it? Yes. So, there are some changes which cannot be made to its original form. So, that is one example of irreversible change. Yes children, you can have a look on plants here. It is of different stage. So, you can see different stages of growth of a plant, isn't it? This is small, this is to some extent big, and then bigger, and this is the biggest, and it will keep growing. So, children, this is one example of irreversible change. So, it will keep on growing. It will never turn back to its first stage, isn't it? So, this is one example of irreversible change. Yes children, now we are going to learn about another type of irreversible change. That is, in irreversible change, there might be a change in internal structure of a substance. For example, the internal structure of an egg changes on boiling, isn't it? The internal structure alone will be changed. Once it is boiled, it will be changed. Yes children, now another example. I am having a plain sheet here. Okay. So, I can tear this paper into smaller pieces like this. Furthermore also, isn't it? Yes. Now here I can change the original paper into smaller one, but still the internal structure will not change here, isn't it? So here no change. Next thing is about the internal structure will not change. For example, tearing a sheet. If you tear a sheet, you can have small pieces, but the structure inside will not change. Clear? Yes. Yes, children. Now, it may also result in the formation of new substance. How? Ash is formed when we burn paper. We cannot change ash back into the paper, isn't it? Yes. So now the changes are grouped together as either reversible or irreversible. We have learned till now reversible and irreversible. Yes, children. Now let us learn about physical changes. Okay. So physical change, a change in which physical properties of a substance change and there is no change in the chemical composition. Okay. So only the physical properties are changed and the chemical composition does not change here. So here for example, melting of ice, evaporation of water, mixing sand and water. These are example of reversible physical changes. And the next type is irreversible physical change. For that, examples are breaking of glass, tearing of paper and bursting of balloon, or these are examples of some physical changes which are irreversible. Clear? Yes. Next thing is about chemical change. So here a change that is usually permanent, permanent in nature and leads to the formation of new substances. It won't exist as the older one. It has changed as a new substance, okay, of new substances with composition and properties different from those of original substances. It won't stay as like the original substances. It will be turned to a new substance, where the new substance are having different composition and properties. So chemically it has been changed. So we are going to learn about that. That is called as chemical change. For example, when a piece of paper is burnt, it changes into ash. A piece of paper, when it is burnt, it's turned to ash. So here the ash so formed is a new substance and the composition, the properties are different from those of the original one, of those of the paper, isn't it? Ash is different and paper is different. They are having different composition and properties. So this is one example of chemical change. Another example, when atoms of hydrogen and oxygen are combined together, they form water molecule, isn't it? Yes. So that is a chemical change. What I said, hydrogen and oxygen atoms are combined together to form water molecule. So that is a chemical change. It cannot be reverted back to hydrogen or oxygen, isn't it? Yes. So this is what about chemical change. Yes, children. Now about fermentation. Okay. So microorganisms like yeast and bacteria break down the sugar into alcohol and carbon dioxide. Okay. So this is a chemical change and also it is an irreversible change where the product alcohol which is formed cannot be turned back to its sugar original position. Okay. So, this is one example for chemical change and irreversible change. So, in a chemical change, the new properties and the composition which are formed that are different from the original substance. For example, just now I said a paper, when it is turned to or changed to ash, then they are having different composition and properties. It is not same as the original substance. Second point, the change, the chemical change is usually irreversible. It is usually irreversible. It cannot be changed back. Okay. Then it mostly involves absorption or emission of heat, light or both. Mostly involves the absorption or emission of heat, light or both. Clear, children? Yes. Yes, children. Now, let us learn about common causes of physical and chemical changes. Okay. So, first thing, mixing of two or more substances. So, now about physical change, we are going to learn about a physical change, that is when some amount of salt is mixed with water, the product what you are getting is solution. Okay. Now, so two things, that is two or more substances are mixed together to get a solution, which is a physical change. Another example, to the lemon juice, if you are adding some amount of baking soda, then you will be hearing a hissing sound and carbon dioxide bubbles are seen in the top of the mixture, Okay. So, two different substances are mixed together and you are getting a new substance, and this new substances, from this new substances, original substances cannot be recovered back again. You cannot get this lemon juice or baking soda separately, isn't it? So, this is one example where it is an irreversible change, physical change and irreversible change. Yes, children. Now about chemical reaction. When ion objects are exposed to moist air, you can see a reddish brown layer, that is rust, on the surface of ion. Okay. So, the chemical reaction is a cause of this change. Yes, children. Now about the third point, heating and cooling. How this is used here to change a property. So, heating and cooling can bring a change in physical state of matter. So, here solid is changed to liquid and liquid is changed to gas when it is subjected to heating, isn't it? Yes. Then again gas is changed to liquid and liquid is changed to solid when it is subjected to cooling. So, here heating and cooling can bring a change in the state of matter. Clear? Yes. Now about application of force. Fourth property, application of force. So, what is this? When a goldsmith hammers gold, he makes intricate design. So, here force is applied to make apparent changes. So, this is what application of force. Yes, children. Now, let us learn about effect on heating and cooling on substances. Heating and cooling of substances. Okay. So, here a metal lid bottle you are just taking a metal lid from the bottle. So, it seems to be tightly closed. So, how to open that? You are just dipping the lid in warm water first, okay, and then invert and dip in hot water, okay. Then remove the bottle from the water, so that you can observe the change, that is, you can open easily, open. So, this proves that the substances expand on heating and contract on cooling, Clear, children? So, do this activity at your home with the presence of your parent. Yes, children. Now, let us learn about application of contraction and expansion. Clear? Okay. So, now the metal drum is usually fitted on the wooden wheel of the cart for smooth movement. Okay. So, here the metal drum expands on heating and it is slipped on the wheel, and cold water is poured on the wheel, so that it fits tightly. So, here when it is heated, it expands, and when it is poured with cold water, it contracts. Okay. So, this is one example of application of contraction and expansion. Yes, children. Now, the second application, that is, rails made of iron expands in heat of summer. Okay. The gaps provide space for expansion. You can have a look on the picture which is there in your textbook also. So, in between the railway tracks, some gaps are there. So, the purpose of the gaps is to, when it is subjected to heat on summer days, when it is subjected to heat, it will expand, so that gaps will be filled. Can you understand? So, this is the second application. Yes, children. Now, about the third application, that is clinical thermometer. Okay. So, this thermometer is used to measure the body temperature. As you all know, it is used to measure the body temperature. So, here the bulb in the liquid mercury, it expands when it absorbs heat from the body. So that mercury level will raise, isn't it? It will raise, and then when the bulb is dipped in cold water, automatically it contracts and the mercury level will be seen falling. It can be seen falling. Okay. So, this is one application of contraction and expansion. So, children, with this we have come to an end of this chapter. So, after watching the video, read the chapter entirely so that you can understand well. Clear, children? Stay home, stay safe. Thank you.